This is Algebra 1, Lesson 6.8, Systems of Inequalities. So we've studied systems of equality or equations, and we would graph two lines and find where those two lines intersect. And we've studied inequalities, and now we're going to put the two together. We're going to graph two inequalities, and we're going to see where their solutions overlap. So let's go ahead. We're going to start. It's in slope-intercept form for us. So we have y equals mx plus b. We're going to start with our b, our y-intercept. So we start at -2 right here. So on the y-axis, we go to -2. And our m, our slope, is right here. There's nothing there except the negative, so we know that really means -1. And if it's a whole number, we put it over 1. So we have a rise of -1, so that's down 1, a run of +1, down 1, over 1, down 1, over 1. We could have chosen to put that negative in the denominator. So that would have a rise of +1, a run of -1. So we could have gone up 1, over 1, up 1, over 1, up 1, over 1. And this line's going to be dashed because the points on the line are not included in our solution. So I'm just going to dash that as best I can. Now, if you remember for inequalities, it's all points that are greater than that line. So greater than means we're going to shade above. If you wanted to check, you choose a point in that solution. Let's say we choose the origin 0, 0. And substitute it back in. You get 0 is greater than 0 minus 2. 0 is greater than -2. That's a true statement. It is in our solution. Now let's go ahead and graph the second line. This time our b, our y-intercept, is at +2. So on the y-axis, we go to +2. Our slope this time is -5. Again, if it's a whole number, we put it over 1. So we have a rise of -5, so we go down 5, 1, 2, 3, 4, 5, over 1. And again, it's going to be a dashed line because there's no bar. The points on the line are not included. Okay. And we want points that are less than, so we want to shade below. So we're going to shade below that line. So the solution for our system is where those two overlap. So in this case, it would be this region right here. So I'll just shade that. Okay, again, if you want to check your work, you choose a point. So maybe -2, +3, right there. -2, +3. If we substitute it in, it should work for both cases. So is 3 greater than 2 minus 2, 0, is 3 greater than 0? Yes, it works in that one. And is 3 less than 10 plus 2? Is 3 less than 12? Yes, it works for both. It's in our solution. Let's try again. We start at our y-intercept, +1. Our slope is -2/3. So again, you choose if you want that negative on the top, or you can put the negative on the bottom, whatever one fits better in your graph. I'm going to go down 2 over 3, and maybe I'll go up 2 to the left 3. Just give us a good line, and this line again is going to be dashed because there's no bar there, so that means the points on the line are not included. And we want points that are less than, so that means we're going to shade down. Now I'm going to graph my second line. And so this one, we have a y-intercept of -2. We're going to start on the y-axis at -2. This one has a slope of 1/3. That means rise 1, run 3, up 1, over 3, up 1, over 3. So somewhere around here. Remember, 1 over 3 is the same as -1 over -3. So if you need more points, you can go down 1 to the left 3. Just to give us a better line. This time it is less than or equal to, so it's going to be a solid line. And we're looking for points that are less than, so we're shading below. So the solution of our system is just where the two overlap. So that's going to be this region here. So again, if we wanted to check, we could choose a point in that region, substitute it in, and see if it works. what happens if they're not so nice and they're not in slope-intercept form? Let's practice one of those. We know how to do this. We simply put it in slope-intercept form. So we have 4x plus y is less than 2. We're going to subtract 4x from each side to get y by itself. So you get y is less than negative 4x plus 2. We're back in business. Our y-intercept is positive 2. Our slope is negative 4, which we know is negative 4 over 1. Down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1, something like this. And there's no bar, so our line's going to be dashed. And then y is greater than negative 2. Oops, I forgot to shade. We want less than, so we're going to shade down. Okay, now our second line, y is greater than negative 2. Remember what that looks like. You go on the y-axis to negative 2, and you draw a horizontal line. Okay, there's no bar, so my line's going to be dashed this time. And we want points that are greater than, so above. So I'm going to shade above my dashed line. And then again, our final solution is where the two overlap. So that would be in this region here. If you'd like to check just to make sure, choose a point, substitute it in, make sure you get a true statement. Please try the practice problems. Let me know if you have any questions. Thank you.